Welcome to the lecture series on radiant heating systems. This will be the last bit of Project 3 and should allow you to complete that project. What we're going to be concentrating on is the in-floor heating system. Radiant heating is generally done through the floor like this, but you can have, of course, more traditional methods as well. The general term is actually hydronic heating. Radiant is usually reserved for the floor heating, but any sort of hot water or steam system would be considered hydronic, and that can include radiators, like these old cast iron wonders, the fin tubes, where you have copper tubing with stamped metal fins running across them, generating heat. Floor tubing can be concrete systems. These are actually the preferred ones if you're doing a radiant heating, because the concrete helps spread the heat out a little better, but that's impractical in a lot of homes unless you're building on a slab. So you can go in through the subfloor as well with these heating plates, insulating underneath and then putting your flooring on top, and this works out pretty well too, as you'll see. In the additional YouTube videos that I ask you to look at, you'll see descriptions of each of these. We've got different little videos to show you how these systems are put together and actually built. In today's world, when we talk about radiant heating, we're talking about PEX tubing. That is the modern solution to the problem. The tubing sizes come for home use 3/8 up to 3/4, and you can see that the spacing of the tube, that is how tight are the loops, depends a bit on the tube sizing, and also the allowed length. You can't have the length too long, or what happens is the boiler doesn't have and the pump system doesn't have enough energy to pump through the hose. One of the truths about fluid dynamics is that if you try pumping too fast or too small a diameter, you will bind and it will airlock and it won't work anymore, and you can only draw so much flow rate. So these are the recommended flow rates in gallons per minute. That's what GPM stands for. Through the various diameters. And you can see as the diameter increases, you get more flow. That's always the case. But, of course, you need bigger pumps and you need a bigger boiler behind it to handle that much flow. Basically, in home usage, the 1/2 and the 5/8 are the two main recommended ones. And you can do spacing. Recommended is 9 inches for the half, 12 inches for the 5/8. You can go up to 12 but our home's in Watertown, that won't be of any use. You can actually drop one as well. So for the half, you can get as low as 6. And that is often done in bathrooms where you want a little extra heat, because people like to be warm when they step out of a nice hot shower. So they'll pack it a little tighter. You can see that the BTU per square foot per hour is around, they base it at 22 to 30 for most construction under a wooden floor. That's about right. It's closer to the 30 today than the 22, especially if you have it professionally installed. If folks like yourself are doing it, it should be closer to the 30. The 22 is more of the do-it-yourself type person kind of number, because you're assuming that you folks are going to do it right. You're going to make the loops properly spaced. You're going to use metal heat spread plates. You're going to do all the right things that get that number closer to 30. So we're going to be using the 30 number for our calculations, and the flow rate, again, we'll use the suggested flow rate on the pipe. Now, what's interesting here with this is that you can play with this number a little bit. If you increase the flow rate just a little bit, you can get the output of the heating up And it's said that for half-inch pipe, if you can increase it to 0.7, you'll add another 5 BTU per square foot per hour of heating to the system. And you have a little bit of leeway there to bump up, but only a little bit. You can't double that flow. You can't get 1.2 gallons per minute out of a half-inch PEX. It just isn't going to work. It's going to put too much. Well, you're not going to get the flow you think you are, and you're not going to be able to get these 300-foot circuit lengths. So, you can bump that up to 0.7 and maybe a little bit higher, but that's about all you're going to get. So these numbers, stick to the 30. You can use it. It will work for your calculations. And how do we calculate how many feet of pipe we need? Well, it really isn't too difficult. This formula set here will help you with that. If you're using a 9-inch spacing, then you take the square footage of the area you're trying to heat and you multiply by 1.34, and you have calculated how many feet of pipe are going to exist in that room. It's that simple. If you're using 6-inch spaces, you multiply by 2. So, and then for 12 and 18, these other numbers. But you can see nice and easy calculation. So for the most part, 1.34 or 2. Those are the two numbers you're going to be using the most because you're going to be working with 6-inch and 9-inch spacing. Well, you're going to need a lot of loops to do this, as you're going to see in a moment. And this is a look at a basement. You can see we got all the pipes coming down, all the PEX, and it comes into the manifold system through a pressure regulator. We've got a pump over here with our thermostatic controls driving this. This is a one-loop system, so all of this is considered one loop on one thermostat. Okay, and this is our circulator pump here. Our pressure regulation system. We got our on and off shutoffs, our bleeds. You can see our low line bleed here to bleed the system down here. Shutoffs here, another bleed here. You're all good to go, right? And this is a very typical system where the PEX all comes flying in and then goes into this manifold system. Because you're only allowed 300-foot lengths, and you've got a house that's much bigger than that, you're going to have multiple set of loops on each floor, and then you, as the installer, have to work with the customer to say, well, how many loops tie into one single thermostat. How many thermostats do I want? How many zones? And once you determine how many zones, you figure out how many manifolds you need for each zone, and then you can roll. Now, I'm not asking you to count manifolds in this project. I figured, given all the difficulties of this semester, I think we'll all be happy if you can just come up with feet of pipe for me, and not even worry about the zoning on this one. I just don't think I can ask too much more of you in the time period that we have left, and the fact that you're working through at home and don't have a lot of nice software that would help you lay out these floor plans. So we kind of have to forego that, but I did want to show you what things start to look like when you put it all together. As we say, we have multiple loops, and you can see here, here we have a set of 3 loops in this room, because you've got 6 pipes. So you've got 3 separate loops here going out, and they're all tying into this one manifold system and are going to be used to heat this space. So you do get these multiple loops. You can kind of see it here as well. Here's a loop here where I'm kind of rolling with the mouse. Here's another one down here. And yet these are all tying in at the manifold. And we kind of have to, when we're laying this out, this is where you need the software, which we now don't have, is where you try to figure out and lay out how do you loop these loops such that you got enough room to run your pipe back and get back to the manifold, and where do you place the manifolds in the room to, get you down to the boiler and everything else. It's not trivial. And unfortunately, we kind of trivialize it on this project because we're trying to do it remotely. So I apologize for that, but there isn't much hope for it. But I do at least want to expose you to the issues that you have to deal with. And there is software that will help you lay out for these rooms. And I chose this photo on the right because I like the fact that, the floor is not rectangular in shape, and yet the piping, of course, the beauty of it is you can see that it works real well. Now here, you don't see any metal plates in the floor. What you do see for the turnarounds here, they're using some fixtures to help make the PEX run nicely and get real nice corners and get that nice even spacing across the subfloor. Here, what you're seeing on the left is you can purchase a grooved subfloor with the grooving already in it and route it out, and you just lay the pipe in it. That is an expensive option, but it is one you can use. In the video that I have for you, the gentleman that's trying to sell you his system has metal plates that he uses along the straight portions of the run, and they help spread the heat. Plus, they also serve to keep the PEX in place on the floor, so they serve a double purpose. And he just drives those home with a nail gun.